Okay, so construct a polynomial function for the graph below. This is actually something that we've already done already. This is the one that uses that y equals a x minus 0, 1, x minus 0, 2, ... formula. There's more stuff that comes after that, but this is the main formula that you want to use for this particular problem. It's just that the zeros, we're going to get off of the graph directly instead of them giving them to us. So I have this one, and this one. Those are going to be my given zeros here. So I have -4, -1, and 2 as my zeros. Okay, so let's just write that underneath. So zeros on this one, the zeros are -4, -1, and 2. From this picture, those are the ones that they gave us. So now we're just going to stick this into this formula. So I have y equals, we don't know what the a value is yet. We're going to do x minus the first zero, x minus -4. Then we're going to do x minus -1. Then we're going to do x minus 2. Then we're just going to simplify this. So y equals a times x plus 4, x plus 1, x minus 2. Okay, so we have it almost complete, except now we just have to figure out what the a value is for this one. Now, in order to use this, we have to put a point, any point on the graph besides the 0. We don't want to use zeros here, because if we put a 0 in there, then you just have everything all cancel out and you get 0. So that's not going to allow us to solve for a. So you don't want to use any of the zeros as your points here, but we want to pick another point that we see the graph going through. So I want to see if there's an exact point that I know exactly for sure where the graph goes through. So this one looks pretty close here, -2 and 2, but I think I'm going to go for, again, I mentioned earlier that when we did this problem before, it's actually good to use your y-intercept here. The y-intercept helps because that's got a 0 in it, and it makes that easy to put in. So on this problem, the y-intercept is 0, -2. That we know for sure it crosses there. It's exact, which means that is my x value and my y value that I'm going to put into this formula, and that's going to allow me to solve for a. Okay, so the y value is -2. The a we don't know yet. And for all these x's, I'm going to put in a 0. So again, that's why using the x-intercept makes that easy, because then you're just putting zeros in for all the x's. Now, you really could use any point you want on the graph, but it has to be an exact point that it goes through on that. So like this one, it looks like it goes through -2, 2. So I could have done that, but then that makes, with something like this, that might make that a little bit, you have to do a little bit more work when you simplify. 0 makes things easy because I have 0 plus 4, I have 0 plus 1, and 0 minus 2. That makes that easy to figure out each of the different results inside the parenthesis there. So I have a times, this will be 4, and then I have 1, and then I have -2. I'm going to multiply all those together. -2 will equal a times, so I'm just going to multiply all this, and actually what I get, let me write the number first. If I do 4 times 1 times -2, I'm going to get -8. So that I can write as -8a. Then we just divide both sides by -8. And as a result there, that reduces to 1/4. Okay, so now I know my a value is equal to 1/4. I'm ready to write my equation. So I'm going to do y equals 1/4. I'm just going to put x plus 4, x plus 1, x minus 2. That is it. That is going to be the exact answer to this particular question here. Let's look a little bit neater here. So this is your final answer there. So this would be the equation that describes this particular graph. So we just put in the zeros. So you do x minus 0, 1. X, it's always a minus when you do this kind of formula. So we always start by doing x minus whatever the 0 is, and you just keep listing them all out like that. That's how you want to do that one. Okay, so we put that in, we plugged those in, we simplified it, And we just grabbed another point off the graph that's not the x-intercepts. Again, you can just use the y-intercept if you know what it is exactly. That's always a good one to use here. All right, so that is the end of this section.